Hello, my name is Ryan Brown, and this is my semester project benchmark for CMSC125. So, what my notebook is about is operating or analyzing a data set released by Ubisoft based on their game Rainbow Six Siege. So the data set came out. Unfortunately, it's the most recent data set which they released. However, it is a few years old, but it basically has data from thousands of rounds throughout a whole 3-month season of all the rounds played, and it includes specific data for each player's chosen operator, which is like the character they play as, the weapons they use, the gadgets, like the secondary gadgets they have, as well as how many kills they got, how many deaths, the number of rounds won, and the number of total rounds played. And basically, I wanted to use this data to try to find any sort of like trends or relationships between, like, for example, like operators and how like operator choice affects win rate. The three specific things which I covered were operator choice versus win rate, to see if there was any sort of relationship with some operators maybe being associated with a higher win rate and some being a little bit lower. Weapon choice versus KD, which is kill death ratio. It's how many players you eliminate divided by how many times your character dies. And then lastly, like your secondary gadget versus win rate, to see if there's any sort of relationship there with some gadgets maybe not leading, but being associated with higher win rates. So that was one of my successes, was I was able to write the code to process all that data and find those three things that I wanted in my notebook in 3 different sections. And then another success was I felt like I made good use of functions, specifically in my last 2 sections, which were weapon versus KD and gadget versus win rate. I feel like I used the functions a lot better, or made use of functions in a strong way to make my code more efficient and minimize the amount of like jargon I had in my code, and making it look a lot cleaner. However, one of my failures, I would definitely say, was my code efficiency. So I'll show you in the notebook in a little bit, but my first section for operator versus win rate, I took a really simple approach, not realizing how long of my code it would be, how many lines I'd have. Basically, I just had a bunch of if and like elifs for each operator, and in each of those if statements, it was basically reading through like the line of data and looking for the operator, and then once I found the operator, it would add the amount of kills that operator had and the amount of deaths they had, and then go through that for all lines. And it was big jumble. It was like 240 lines, but luckily I was able to fix that for the next 2 sections, realizing there was a much better way to do it. And then also, I said a failure was reading the prompt, because I had to go back in and change some of my code, as I didn't fully realize you need like 2 functions, whatever, like 3 loops, 3 if statements, that kind of stuff. So I should have done a better job initially just reading that. The things I learned, I would say the biggest thing was the use of dictionaries in Python. It's one of the data structures that we used, and I think this will be really helpful for the final exam. I used dictionaries for my last 2 sections, and that's what made my code a lot more efficient. Rather than having all those ifs and elifs, I was able to just use, basically, I think they're called nested dictionaries. It's using this website like W3 something. I was able to like learn a bit about it, and basically it's like so I had a dictionary for all for example, like the one section I did, weapon versus KD. I would have a dictionary which was all the weapons, and then each weapon had an associated dictionary with it, and in that associated dictionary was the kills, the total kills, and the total deaths associated with that weapon. And then basically each time the code ran through a specific line in the CSV table, it would basically for that weapon it would add kills and then deaths to the dictionary associated to that weapon that it found in that line. So I learned a lot about dictionaries, and then this like touching up on the syntax that goes with it, with like the curly braces, and then like when accessing them, the square braces, and then also, like I kind of mentioned earlier, like using other resources. Like we didn't, like obviously we didn't touch on nested dictionaries in class, but like using like that website W3. Obviously, like in the future, like if I'm programming, there's gonna be a lot of stuff that we like didn't touch, but I got like some good experience like using a website like that to like learn how I can apply these. I don't want to say more abstract things, but the more complicated programming like techniques that I didn't learn in class, for example, as well as like the syntax that go with it. So for the peer review, one thing which someone mentioned that I thought would definitely be helpful to like change or like add to my notebook was basically like making use of the data. Like originally I was just talking about how like developers of the game could use it, but like really how like a player like myself could use it. So yeah, unfortunately Ubisoft doesn't release the data to the public anymore. They kind of like keep it to themselves and do their own kind of analysis each season. But it's not like the same kind of stuff I was doing. But like basically like I added in stuff how like I as a player could use, for example, like operator versus win rate to see like, oh, maybe some of the operators are more stronger, and if this operator's associated with a higher win rate, maybe that means he's stronger, and maybe I should be using him more. Or, oh, this gadget is associated with a lower win rate, maybe I shouldn't use that gadget. It's maybe not as good as others, that kind of stuff. So I added a bit of that to my notebook. And then also a lot of something that a lot of the people said was like acknowledging the limitations of the data due to its age. So as I mentioned, it's a couple years old, and the game has obviously changed in that time. The game's still pretty active, and there's constant seasonal updates every 3 months. So with that, the data, you should take it, I don't want to say with a grain of salt, but it's not as effective as if this data would have been released yesterday about like the current state of the game, because it has changed, obviously. So unfortunately, like in the modern day, you can't really use it as effectively as you would. So that's something I kind of acknowledged in my notebook. So for the notebook, here it is. This is just my introduction section, talking a bit about like what the notebook is. Here's talking about like the data set, what it all includes. I sort of already touched on that. Yeah, there's some more information though, being a little bit more specific to like what I didn't already mention. And then here's my first section, operator choice versus win rate. So as you see, this is just every single operator in the game, and for each operator I made like a round win variable and a round total variable, and obviously I had to initialize them all to 0. So this is a big mess. And then the 4-line in data part, where it's basically just a bunch of if and elif statements, basically like if in this certain column it finds that the operator is this operator, then it changes that operator's wins total and round played total or it adds what it finds in the win column and the round played column, and it does this for all operators. So this definitely took a while. It was really tedious, and it's definitely not as efficient. It was 259 lines, a lot for really not a lot of like data processing, just because of the sheer amount of operators in the game. And then at the end, for the input, I just kind of had it. So rather than putting all the operators, it was kind of like you inputted, I just want to look at attackers or defenders. So that it was a little bit less messy. And then it just prints out all the associated win rates with print statements. Like this is terrible, but for the next two sections, we'll see I fixed it. This is weapon choice over KD ratio. So I basically had a function which takes in a library which is like all the weapons. W would be the W parameter would be what weapon, K is kills, D is deaths. This first part is just because the CSV has a header row that has a bunch of stuff like saying what that column is. So you kind of had to like get it out of the way. Otherwise, it'd lead to errors, like trying to make like an integer, like turn K into an integer if K is a string, and like you can't do that, or like a string of characters. And then here it's basically just changing that nested, those nested dictionaries, and yeah, and then here's just like the empty, or basically how this function works is like it's rather than making a dictionary with all the weapons because there's so many, it's basically just like if it doesn't find that weapon already in the dictionary, it makes a new weapon in that dictionary and its associated kills and deaths dictionary. So that cleaned up real nicely. And then for the for loop, all it is it's just weapon kills deaths equal to what the associated column is, and then it just runs that function. Function doesn't have to return anything; it just changes the library. And at the end, you just for each weapon and weapon stats, you're just printing the weapon and its associated KD. And then lastly, it is secondary gadget versus win rate. It's a really similar code to here, to the weapon versus KD, just some change things. Obviously, wins and rounds versus kills and deaths, and gadgets instead of weapons. But I used mostly the same format and same idea for this. And then it just prints them all. Yeah, so that was my notebook. I hope you enjoyed. Thanks for listening.